That's the answer. It is progressive. You could stop playing football, and then the disease could progress over the years that you're not even getting impacted. CTE is like a spreading disease. Like it starts in one area of the brain, let's say, and then you stop getting blows to the head, but then you can get it later. Why some people get it later and some people don't, nobody knows. But
Hello, everyone, and welcome to the second episode of the Dr. Snow Brain Health Show. My name is Scott Alford, and I want to hand it over to Dr. Snow to talk a little bit about the format that we're going to be using week in and week out.
yeah, Scott and I talked about this, that I really didn't want to know what his questions were each episode. So we discussed about, picking a topic about brain health. That's what we're going to do on this show every week. And I really don't know the questions that Scott's going to ask me about in each episode. So in that way, it's a conversation. I don't, I might have to look up something on the backside, on the research side, but most of the questions I have no idea what Scott's going to ask each week.
So for today's episode, in our second episode, I thought we should talk a little bit about CTE. And I remember growing up in Cincinnati with Chris Henry and the tragic accident that happened to him. And I know that they, post-mortem, took a look at his brain and saw how severe the CTE in his brain was. So it's been a topic that I've been interested in for quite a while. But I want to talk a little bit for those in the audience and ask about what is CTE for those who don't know. What is it exactly, and what's interesting for us to understand about CTE?
Yeah, CTE, for people who don't know what it stands for, chronic traumatic encephalopathy, CTE. It's been studied actually quite recently, I'd say the last 10 years, really by a prominent neuropathologist out of Boston University, Dr. Anne McKee. She ended up doing all the autopsies within the last 10 years and found that, and I have the numbers because I actually went to one of these conferences. So she holds the CTE conferences in Boston. Actually, it's coming up in a couple of weeks here, end of November. And I attended one of these conferences a couple of years ago. So I was in the room listening to all these researchers for like 2 to 3 days, talking about CTE, talking about there was NFL players who were worried about it, basically getting blows to the head. It doesn't have to be concussions, but repetitive blows to the head in football and soccer and ice hockey and skiing and all these high impact sports. Basically, when they looked in the brains, and this is at autopsy, so they're not doing it in live patients, they actually see the pathology of neurofibrillary tangles in the brain. So if you remember when I talked a little bit about Alzheimer's disease, people start getting plaques and tangles. Plaques are like these Swedish meatballs in between neurons, and tangles are inside the neurons. So football players just get tangles in the brain. They don't get plaques, and that's why it's a different disease when you talk about chronic traumatic encephalopathy, let's say, versus Alzheimer's disease. And again, this is all done at autopsy.
So I want to emphasize one thing that you talked about. You mentioned that CTE is not exactly the result of concussions. And I know that there's a prominent or famous movie that Will Smith was in with Dr. Bennett Amalu, and
He played Dr.
he
Amalu.
played the doctor. Thank you. What does cause CTE if it's not concussions?
Well, by the way, that movie was probably, I'm not going to be political about Will Smith and what he did at the Academy Awards or whatever, but that movie where he played that neuropathologist reminded me of myself, because I'm a PhD in neuropathology. When I was, helping out University of Washington Alzheimer's Disease Research Center, I was part of the autopsy team. So I would come in and help them get the brains and freeze half the brain, and that was used for research. Basically, you got to preserve it. We're trying to get the brains within 4 to 5 hours after death. So I was actually on call. The same thing here. This is a neuropathologist, and I think it started with like Mike Webster, who committed suicide at about age 50, 52. And he was a football player, and he had emotional disturbances. He ended up shooting himself, I think, in a truck in the middle of a field. And, this was obviously abnormal behavior. Another example is Junior Seau of the San Diego Chargers ended up killing himself, committed suicide in front of the rest of the coaches and the rest of his team. And this is all leading from blows to the head. And apparently over the years they found it's not really the concussions that knock you out. It's these minor, hits to the head every play that goes on for football players, since they start in high school. And it's just the accumulating over time. That's the problem. And by the way, it varies from individual to individual. So there's no real reasoning why this person will have the emotional disturbances and suicidal tendencies. And by the way, they have memory loss as well. But it's interesting because it's in a different location of the brain than it is in Alzheimer's disease. So in Alzheimer's disease, more like frontal cortex. In CTE, it's more in the grooves of the brain, so the folds, and you actually see the tangles in the sulci of the hippocampus in the cortex. So it's in a different location. And the interesting thing about it is that the location is basically, where your emotional disturbances occur, where you could also have memory loss because you're losing neurons, just like in Alzheimer's disease, you're losing neurons. But it's in a different location. It's more sort of emotional outbursts, on the edge type of personality.
So one of the things that is popular, whether you go on YouTube or TikTok, are people who are speculating about players like Antonio Brown or other players and saying, oh, look, evidence of CTE here, there, and this interview. What is wrong with that thinking in terms of like talking about the symptoms of CTE for people that are alive?
It's really interesting for me to look at the advancement in science within the last 5 to 10 years. 5 to 10 years ago, we could never look at amyloid plaques in the brains of live patients. And now they've developed PET imaging techniques where they could shoot a radio label into your arm and it actually goes right to the amyloid plaques if it's there, sticks to it, and then it lights up so the neurologist can actually view this in live time in live patients. So that's been an amazing advancement. Within the last 5 years now, and I've been looking up this research, you can now see tangles in the brain in live patients, in Alzheimer's patients. And I believe that within the next 5 years, we're going to be able to PET image football players and look at their tangle load in the brain in live patients. And so
Okay,
that's going to be huge.
that's good. So that's going to change. So
This
the fact that people can only look at the brain now after people die,
That's right.
that's not going to be the case in a couple of years.
I believe so. I believe in 5 years, the PET imaging techniques for tangles in the brain is going to be so far advanced that we could use that to look at tangles in football players and people who we think may have CTE.
That's really neat. So I know you talked about Dr. Ann McKee. Can you expound a little bit upon some of the research that she's done? I know you said she looked at the brains over the past decade, but what other interesting things are you noting in her research, the research of her team, or the research of others that are in that similar space that make you think that there's a lot of advancement that's going to be coming in the next 5 years?
Well, she's quite amazing in that her whole team at Boston University were getting the brains donated by many people, NFL players, families, ice hockey players, soccer players, anybody who had potential head injury and had sort of, weird symptoms, outbursts, suicide at the end of the day. And, I attended her CTE conference a couple of years ago, and I couldn't believe the data that she was showing. I mean, they did like 500 to 600 autopsies, and 90% of these autopsies had CTE, like 90%. And I could, the numbers change, and I looked at them recently, but 40-50% of ice hockey players, 40-50% of soccer players who came to autopsy had tangles in their brain, and they were stage 2 to 3 CTE. She stages them in around 4 different stages, and it just means like stage 4 has the most tangles, stage 1 is a few tangles, stage 2 is more tangles in the brain, stage 3 is a lot more, and stage 4 is loaded. And a lot of the football players were coming in and getting diagnosed with stage 3, stage 4 CTE, which means their whole brain is like filled with these tangles. You could pick it up, you could detect it with an antibody to the tau protein. So if I took a piece of brain tissue and then I stain with a particular antibody that picks up the tau protein, abnormal phosphorylated tau protein, you could actually see it. So it turns brown. So a normal brain wouldn't have all these tangles in it. But the football player that keeps on getting repetitive blows to the head shows a lot of tangles. And hopefully we'll insert some pictures that we could show the audience when we talk about it, because I do have a lot of slides on this.
Okay, this is really interesting. So the brain staging that you just talked about. So I know Aaron Hernandez, for example, was really severe recently. Rest in peace, Demarius Thomas. Same kind of thing. So out of curiosity, like these tangles form, how do we measure the significance of tangles? Is it the size? Is it the number? Is it where they're located? Like, how do we distinguish between certain kinds of tangles even in CTE?
So it's the number of tangles and the location. You'll just start to see them, and they just, start accumulating. And basically stage 4 is like there's a lot of tangles. I don't think there's a quantity that she came up with this basically measuring system, and it's very simple. It's almost like stages of cancer, advanced cancer versus early stage. So a few tangles, stage 1, lots of tangles throughout different areas of the brain, stage 4. So the more tangles you have, the more also, the symptoms that you see, the suicidal tendencies, the memory loss, the outbursts, tends to be more in like stage 3, 4 CTE than stage 1 or 2. So there is a slight correlation to having more tangles in the brain. You're going to have more clinical symptoms. In the end, a lot of these people committed suicide. And so when they came to autopsy, they were advanced CTE, chronic traumatic encephalopathy. The other interesting thing about this, Scott, is that, and I had to go through my notes and everything, that once they get hit, let's say in high school to early college, if they stop playing football, do you think that the disease advances?
This is just a guess. Based on Demarius Thomas, his seemed to get worse and worse and worse even after playing football. And they said that his family said they were surprised because they thought, oh, it would stop at a certain point, but they saw it as being progressive in its development in its brain.
So that's the answer. It is progressive. You could stop playing football, and then the disease could progress over the years that you're not even getting impacted. So it's almost like a prion disease, which is basically infectious proteinaceous particles that spread from one area of the brain to the other. CTE is like a spreading disease. Like it starts in one area of the brain, let's say, and then you stop getting blows to the head, but then you can get it later. Why some people get it later and some people don't, nobody knows. Okay. But I could see a lot of the, NFL players, like quarterbacks that are getting hit in the head in the early years. Later on, when they quit, they're all worried about getting CTE later in life. So that's obviously a major concern.
So the doctor that Will Smith played in Concussion actually did a kind of like a public service announcement, but he directed it at Tua of the Dolphins and said, "Look, retire now." So is his
Really?
advice still sound in relation to that, or you're saying no, that actually doesn't solve the problem?
It doesn't solve the problem because if some people quit, they may not get more progressive CTE. And in this field, it's really an open field as to what's going on. I am doing a research project with Dr. Ann McKee. She sent me brain sections from controls and various people who have been diagnosed with CTE. And I'm actually looking for something else. I discovered in the late 1980s, early 1990s, that there's a protein carbohydrate in the brain. We talked about this a little bit called heparan sulfate proteoglycans. And we could actually form plaques in a test tube and tangles in a test tube. And it's basically taking the tau protein. Let's talk about tangle formation. If we take the tau protein, the same protein that she finds in the brains of all these people, and we add a heparan sulfate glycosaminoglycan, which is the carbohydrate portion of the protein carbohydrate. If we add like heparin to tau, it actually forms twisted paired helical filaments that look identical to what you see in the brain of people who have CTE or tangles in Alzheimer's. Same thing. Paired helical filaments, straight filaments. So what does that mean? It means like, is something going on with heparan sulfate that can be causing tangle formation? I'm looking into that. So I'm doing a project with Dr. McKee. I had to sign a material transfer agreement with Boston University to get over the materials. We're trying to get National Institute of Health funding for this, but nobody knows why the tangles are forming. So if you get a blow to the head, it shakes your head. So that's, part of the thing that they think is going on. The shaking of the head is not good for you, obviously, but that also causes tangle formation. But what's going on with the heparan sulfate during the tangle formation? I think the shaking of the head is actually causing heparan sulfate to come out first and then cause tangle formation. So that's what I'm going to be looking at. And this is going to be a multi-year project, but we're starting to look at this right now, actually.
How did the conversation start around this project? I'm just really interested in how do
How
you
it
start
goes.
these conversations? Is it something that you all are reading one another's papers and you're like, you know what, we should collaborate? Is it like you're at a conference and you end up in
It
side
was in a,
conversations?
yeah,
Good.
I was in the conference in Boston at her CTE conference. So I'm in the room. So it's a small conference, like 100 people. You got to be really interested in CTE, concussions, head injury. So I was starting, and actually, I think I just watched the Will Smith movie, and I was going, wow, this neuropathologist just started looking at the brain tissue of all these football players who died very early in their life, age 40, 50, 60, 20s. And he started, seeing the tangles. I got really interested in it. So I went to my background is I'm a world expert on plaque and tangle formation. So I've been studying tangle formation in Alzheimer's disease for like 30 years. And I said, wow, here's another way of getting tangles in your brain, and it's not aging or Alzheimer's disease. It's basically blows to the head. So I went to the conference and she was there. And during the breaks, I was talking to her. I said, you still don't know what's causing the tangle formation. I discovered these, protein carbohydrates, and I really think they're important in causing the disease that you actually see in the brain. Maybe I could get some brain tissue from your group and, actually get it over to me. And she agreed to do that. And that's how it all started. It was a conversation at a conference. And, that's how I started getting into it, to get those tissues over to it. And it took about a year. I mean, it was a lot of back and forth. And, by the way, these tissues are hard to get. First of all, everybody wants them. Okay, so think about across the US, all these research groups are starting to look into CTE, and there's only so much brain tissue you can get in sections. So they're cut sections, they're unstained, they send them to you. It's a big deal. So for me to get I think I have about 20 brains from CTE patients and 20 controls. That's hard to get. And, we use every single brain tissue section very wisely as what we're going to do to it. What are we going to look for? How are we going to stain it? How are we going to look under microscope? How we're going to document it? I told her we're going to publish papers on positive research that comes out of this. Like if we find something, we're going to publish it with her. So that's how it all came about.
This sounds really exciting. So I want to actually circle back to a topic that we talked about earlier, but I think would be really interesting to learn from the audience. So we talked about how it's not concussions, it's these more minor but persistent, repetitive blows to the brain or trauma, or however you would like to define it. How did we discover, if we can only look at these brains after people have passed, how did we notice that trend? Is that just a general trend that we started to realize that it's not the severity, but it's that continuous blow to the head? Like how would researchers figure that out?
So I think it's really like accumulating all the data over time. And, she's the one who has a lot of collaborators, and they really look at the history of these football players or whoever comes to autopsy. Like they get their family members, what happened during the last 20 years. He played football in high school for how many years? For 5 years. Talked to his coach in high school. Did he get, how many times was he taken out of the game for a concussion? How did he respond? Was he on some, did they keep him out? So they pull over all the history in these players over the years, and they start to accumulate the data and look at it. So epidemiological studies, basically looking at history of players and what is known about them over the last 20 years, or since they were starting to play, whatever it was. Even if it was a soccer player, how did they start? How many years did they play? They talk to
Mm-hmm.
the coaches. So they get a lot of good history of what's going on with these players. And all of a sudden they commit suicide or emotional disturbances. They're talking to the parents, whoever, the girlfriend, whoever was living with them, and that sort of thing, fiance, etc.
Yeah, so I wanted to play football in high school, but my mom said not a chance. Not a chance
Really?
with
Wow.
she was concerned about a lot of this way back then. If I was a football player, right? Or if you were to meet a football player and they came up to you and said, "Look, I'm worried about the accumulation of these tangles. I'm worried about CTE. I want to think about how to protect myself in terms of prevention, or are there ways that I can be improving my brain health, whether it's my diet, the way that I work out? What insights would you have for someone who is playing football or any sport?"
We did a lot of research. We talked a little about what I do in the natural products company that I formed in 2015. So we actually discovered a plant out of the Amazon rainforest called cat's claw or Uncaria tomentosa. It's a woody vine that grows 200 feet in the jungle, basically. And the Peruvian tribes used it as a medicinal plant. We actually found that it gets into the brain in a few minutes, and in plaque producing mice that have a bunch of plaques in the brain, starts reducing them. And it turns out to be the polyphenols in the cat's claw that's very effective. Well, we found out it not only does that, but it also inhibits tangle formation. And once tangles are formed, it actually can cause it to fall apart. So we're thinking, wow, well, maybe we should just be having a dietary supplement for the brain or for brain health. And, we ended up developing a product called Sport. Sport, and it's not for diagnosing or treating a disease. It's a dietary supplement for the brain, but it does tend to inhibit tangles. And we showed that in a 2019 paper. And then in 2021 in Nature Scientific Reports. So get this, my partner, Dr. Rudy Tanzi, is the concussion coach on the field of the New England Patriots. And when we came out with this dietary supplement, it was around 2019. Tom Brady was on the Patriots team at the time still. They all started taking Sport, this product. And, they were just using it for brain health. We don't want to, say that it does anything, but we had, data on it. I actually have some of it here. This is it. It's called Sport. And we sell it on our website, perceptivebrain.com, on Amazon, Walmart, whatever. But we do have a few football teams on it, and they take it just as a daily, brain supplement. And the interesting thing about it is we showed in major research papers, including a 2019 109-page paper that took 10 years basically of research for me to finally publish it, that it inhibits tangle formation. And you could actually take tau and heparin and actually form tangles in a dish. And then when you add this dietary supplement to it, it just falls apart. It breaks it apart. And it has to do, again, with the polyphenols in the cat's claw. And also there's oolong tea extract that have polyphenols in there that are actually able to attack the tangle formation, which is actually quite unique. And we have patents on the composition and all that kind of stuff. But again, it's not intended to diagnose, treat, cure, prevent any disease. We use it basically as brain health supplement, and a lot of athletes are now taking it, Sport. So, I mean, that's something that you could do. What else can you do? I think that when they come up with PET imaging in live football players, live patients, that they could actually see the tangle load in the brain and don't have to wait to autopsy, that's going to be a big deal. And that could happen, I think, in the next 5 years for sure. Because I just started seeing papers coming out, and now we can look at both plaques and tangles in the brain of live patients simultaneously in the same sort of neurology scan. And that's quite amazing.
Yeah. Wow. So, out of curiosity, and we mentioned this, but I'd like to do a deeper dive. You have tangles that you mention with CTE. You have tangles, if I remember, is it with dementia?
With Alzheimer's disease.
With Alzheimer's disease. So, what is the biggest differences? But also, what are the similarities you see between those tangles? Like,
it's
what
really good,
are the big
Scott.
differences? What are the similarities?
So the differences are Alzheimer's disease have plaques in the brain, and CTE do not have plaques in the brain. What's causing the plaques? Nobody knows. I mean, that's, it's a huge discussion.
It's the billion-dollar question, quite literally.
But the similarities is that both Alzheimer's and CTE have tangles. What's the difference? The location of the tangles. So like I talked about, the location of the tangles in CTE is in the grooves of the brain. So, you have, if you ever see a brain, you have folds. It ends up in the folds. in the folds that are important for emotional well-being. That's why there's a lot of disturbances, abuse, suicidal tendencies. But get this, both of them have memory loss problems, okay? So people who have CTE can have memory loss. They forget things, just like an Alzheimer's patient, but they could be 30 years old. So 30 years old with tangles in the brain, and you have memory loss, similar to a 60 to 70-year-old with Alzheimer's that has both plaques and tangles in the brain. Different locations, but yet you're getting dying neurons, and it's a neurodegenerative disease, which means, there are loss of neurons. In fact, I was reviewing some of my slides, and I was looking at Aaron Hernandez. Dr. McKee had images of his brain. A lot of shrinkage. That brain is small, compared to a normal brain, and very enlarged ventricles. So huge ventricles should be smaller. Brain shrink.
Explain that. The brain overall is smaller, but there's certain things that are larger
Yes.
or inflamed.
Yeah, so the ventricle is sort of, where things are flowing through your, cerebral spinal fluid. They should be a certain, distance, like an opening, like almost like an artery, right? There's a hole. And if you have an atherosclerosis, you have blocked arteries, so they get smaller. But in Alzheimer's disease, you could have enlarged ventricles. They get bigger, which means you have less brain tissue, more shrinkage, larger ventricles. You see that in CTE in some football players like Aaron Hernandez, who came to Autopsy. So I was looking at his brain. I was going, wow, very enlarged ventricle. I could show you the pictures that we could add to this video, because I have it. And this is from Dr. Ann McKee. So she did the autopsy of some of these very famous football players. And you could note that just looking at the overall brain, that there's differences. And shrinkage shrinkage means you're killing neurons and you're losing neurons, and it's neurodegeneration that's occurring as part of this.
This is such an interesting topic. And I know it's something that I'm interested in. I know our audience is interested in. Anybody who follows college, professional, or even high school sports really cares about what's going on with CTE.
One of the other things I just wanted to add to it, it's not only football players, people prone to head injury, it's also veterans and Army, people who've been at war, post-traumatic stress disorder. But we're talking about people who came to autopsy. The blow up of the grenade in the head area also can lead to CTE as well. So Dr. Ann McKee, I remember when I was looking, and we could provide that in this video, I could show you the statistics on this. A lot of veterans also, 60-70% that come to autopsy have CTE, tangles in the brain. So it's not just sports.
Wow. Well, that's something that we should probably investigate in another episode here soon.
Yep.
Thank you so much, Dr. Snow. Really appreciate your time and your insights into CTE and what's happening in the brain, so that we can improve our own brain health.
And I'll keep you updated on the research that we're doing. If we're starting to look at sections actually in the next few weeks, and if we come up with anything, we'll talk about it.
All right, please do.
Okay, great. Thanks, Scott.
Thank you, Dr. Snow.